So good evening everybody. Thank you to be here for the last lecture of our seminars in the Print 2022 project, Synchronized with Nature, Measuring Time in Ancient Egypt and Mesopotamia, Archaeological and Textual Evidence. Today we are honored by the presence of Martin Sweatman, assistant professor in the School of Engineering at the University of Edinburgh. He teaches chemical engineering and his professional research focuses on statistical analysis of atoms in thermodynamic systems like liquids and gases. He developed a true interest in Gobekli Tepe around 10 years ago and has since published several papers and a book that provides an astronomical interpretation of some of its symbols. The Today talk, a solar calendar at Gobekli Tepe and a comet cult at the origin of civilization, he will show that a solar calendar is likely encoded on a pillar at Gobekli Tepe and also explain why it is there. So the floor is yours. Please, Martin, we are here to listen all your discoveries. Please.
Thank you very much, Daria, and also thank you very much to the organizers. So my first task is to try and share my screen, which I'll do now. Okay. So hopefully you'll let me know if you can't see my presentation.
Yes, we see.
Okay. So yes, I'm Martin Sweatman from the University of Edinburgh. I'm not an archaeologist or a historian. I'm actually a theoretical physicist by training, but I now teach in the chemical engineering school here in Edinburgh. And like many people, I had an interest in ancient civilizations and megalithic structures, which then led me to an interest in Gobekli Tepe. And this interest in turn led to some insight into the likely meaning of some of Gobekli Tepe's symbols, which I published in 2017 together with Dimitrios Tsikritsis. And because of my background in the statistical analysis of atoms and molecules, I found that I could use some basic statistical ideas from my professional research area to support this interpretation, and especially the interpretation of symbols on one of the megalithic pillars at the site known as Pillar 43. And here it is. So now specifically in the 2017 paper, we explained how Pillar 43 can be viewed as a memorial to the Younger Dryas impact event, because its symbols likely describe the date of the impact event using precession of the equinoxes and where the animal symbols represent constellations similar to ones we are familiar with today. So that's the ancient Greek ones. And we had some ideas about how to interpret a few of the other pillars at Gobekli Tepe as well, but I want to focus mainly on Pillar 43 in this presentation because it also appears to display a solar calendar. And the aim of this talk is to explain how that works and why that solar calendar is there on the pillar. Now we'll have a lot of ground to cover first before I can discuss that. So I'll be going through a lot of other material first, so you'll need to be a little bit patient. So I've discussed, or I've mentioned the Younger Dryas impact, but what was that? Well, briefly, it's thought that multiple fragments of a broken comet impacted with Earth at about 10,850 BC, plus or minus 50 years or so. And it's thought that this was a massive event distributed across one side or hemisphere of Earth, mainly affecting North America, but also impacting South America and Europe through to the Middle East. And it's called the Younger Dryas impact event because it's claimed to have been the trigger for the Younger Dryas cooling, which seems to have occurred simultaneously across North America and Europe and resulted in a return to near Ice Age conditions for over 1,000 years. Now, unfortunately, I don't have time to go into many details for this hypothesis here, but the best evidence for the Younger Dryas impact comes from the base of the Younger Dryas black mat, and you can see an example there from America. So this layer of discolored sediment, which you can see, appears widely across North America and Western Europe, and it's even been found in Central and South America and in Turkey and Syria. It doesn't always look like this, though. It varies considerably with location, but usually the microscopic signals of what is interpreted to be a cosmic impact are found at the base of the black mat. So the main signals are an excess of nanodiamonds, platinum, and iron-rich microspherules, which look just like impact microspherules, along with other kinds of melted and shocked mineral. Now, it has to be said that the Younger Dryas impact hypothesis remains very controversial, with a series of critical papers and rebuttals to those papers published over the last 10 to 15 years, and some of which are shown.
Sorry, I don't know if you are trying to go with the slides, because you are on the first one.
Right, so I'll just quickly run through you the slides that I had up
Thank
until
you
that
very much.
point. Okay, so that's the introduction. I introduced a paper in 2017, which was with Dimitris Sakritsis, where we analyzed some of the pillars at Gobekli Tepe, and we focused, in this presentation, I want to focus on this pillar 43, because it's the one with the solar, we think it has the solar calendar on it. And we think that this is a memorial to the Younger Dryas impact. And so I mentioned the Younger Dryas impact, about how it's a controversial idea, but there is a lot of evidence, I think, and in particular, a lot of that evidence is found at the base of what is known as the Younger Dryas black mat. And so this is in the form of nanodiamonds and microspherules and different kinds of melted and shocked mineral. And so there have been a series of papers over 10 to 15 years that have gone back and forth, arguing for and against the case for the Younger Dryas impact. Okay, so that gets us back to where we were. And I trust you can now see my slides okay.
Yes.
Yes, okay. So how would this event have affected the region around Gobekli Tepe? Well, there's clear evidence of a cosmic impact in a debris layer at Abu Huraira, which is one of the world's earliest settlements and only about 100 miles south of Gobekli Tepe. So, for example, Andrew Moore and colleagues have found minerals in this debris that were melted at temperatures in excess of 2,000 degrees Celsius, for which the best explanation is a cosmic impact. And this layer has a radiocarbon date consistent with the Younger Dryas impact. There are also anomalously thick layers of charcoal in a couple of lakes in central Turkey, and reported by Turner et al. In this paper at the bottom right there, with radiocarbon dates compatible with the Younger Dryas impact. So these layers in these lakes could be an extension of the Younger Dryas black mat to Turkey. Okay, so that's enough about the Younger Dryas impact. What I want to focus on for the rest of this presentation is some of the evidence which supports the astronomical interpretation of Pillar 43 that I mentioned earlier, and especially the likely appearance of the solar calendar. I haven't got time to go through all the evidence, so this is just a selection of some of the key points. More of the evidence is presented in this paper from last year. But before I go through that evidence, I just want to give you a bit more context about Gobekli Tepe. So it's up here in southern Turkey, just north of Syria, and it sits at the heart of the Fertile Crescent. And the oldest radiocarbon dates found so far are around 11,500 years old. And Abu Huraira is to the south, about here. And I'll discuss a little bit more about that later. And I think Çatalhöyük is over here to the west of Göbekli. And I think Jericho is somewhere around, or perhaps under these labels that I have at the bottom there. So Gobekli Tepe sits on top of a hill overlooking the Haran Plain to the south. So it's an excellent place for naked eye astronomy. So this is what the excavation site looked like when I visited a few years ago. So you can see it's very big. What you're looking at are the four main excavated enclosures, but these are just a small part of the ancient site. So the rest of the site, revealed by ground-penetrating radar, is much larger again, and probably has perhaps a dozen or more large enclosures like the ones that you're seeing there remaining to be excavated. So here is a more recent and detailed map of the excavations around enclosure D, which is the blue enclosure in the middle there. And it shows different phases of construction for these enclosures, because they were built and rebuilt many times. And it's enclosure D that contains pillar 43. So you can see there that the oldest radiocarbon dates published so far correspond to this section of wall here of the enclosure D, and to a half outside of the enclosure D close to bedrock. And they date to, as I said, around 9,530 BC with an uncertainty of about 200 years or so. But this section of wall of enclosure D, the dark blue section at the bottom here, the south, that is significantly, that hasn't been radiocarbon dated yet, but it's thought to be even older than the part that has been dated. So it's possible that this enclosure dates to before 9,600 BC, which would mean that Gobekli Tepe could be a Paleolithic construction. Now this is enclosure E, which lies outside the main excavation area. And you can see it was once an enclosure like the others because it has a pair of stone sockets here in the middle of the smooth bedrock floor. But its walls and pillars are missing. So were they reused in the other enclosures? Perhaps. If so, then it could be even older than enclosure D. Unfortunately, it hasn't been radiocarbon dated yet, but it does at least suggest the possibility that Gobekli Tepe could be substantially older than those radiocarbon dates. And remember, only a small fraction of the site has been excavated so far. Okay, so that was a brief introduction to Gobekli Tepe. So now I'll go through these 8 items quite quickly. So let's first go back to Gobekli Tepe and look at pillar 18. So this is one of the tall central pillars in enclosure D. So this is the same enclosure that has pillar 43. And let's compare the front of pillar 18 with the Nebra sky disk. Now the Nebra sky disk is a Bronze or Iron Age artifact from Europe. And it's widely considered to show astronomical symbols. So we can see that obviously we seem to have the sun and the moon. We have 7 dots, which are widely recognized as symbolizing the Pleiades, which is a star cluster adjacent to Taurus. And there is also at the bottom, there is this curved streak. It's not clear what it is, but it might symbolize a comet. And now let's look at pillar 18. I have a few pictures here. So we have at the top of the pillar underneath the head what appear to be the sun and the moon. And here we have at the bottom of the pillar, at the base of the pillar, we have 7 birds. And in widespread myths, the Pleiades are often represented by either 6 or 7 birds or sisters. And here we have this belt buckle and loincloth that looks somewhat like the head and tail of a comet. So pillar 18 has some similarities to the Nebra sky disk, which is accepted to show astronomical symbols. So perhaps the front of pillar 18 also shows astronomical symbols. We should at least be alert to the possibility for more astronomical symbolism at Gobekli Tepe. Okay, so now let's go back to pillar 43. So clearly, this disk on pillar 43 could have the same meaning as this disk on pillar 18, although the one on pillar 18 seems to have a hole in it, which presumably has some additional meaning. So it's reasonable to propose that this disk on pillar 43 might also symbolize the sun, and therefore it's possible that these animal symbols might be constellation symbols. Now this should not be very surprising. It's frequently argued that the symbolism at Gobekli Tepe is consistent with shamanism, and there are well-established associations between the shamanism and astronomy. See, for example, Ed Krupp's book. Moreover, Hayden and Villeneuve find good evidence that complex hunter-gatherers, even in the Paleolithic period, before Gobekli Tepe, often tracked the solstices and equinoxes. And the people who built enclosure D are probably complex hunter-gatherers, So if that disk is the sun, then we should not be too surprised to also find symbolism for the solstices and equinoxes. And so that reasoning supports the identification of these four symbols as solstice and equinox markers. So we have the sun here, and perhaps these other three are sunsets corresponding to the other three solstice and equinoxes. We think the sun represents the summer solstice. So they don't have to be that interpretation, but it establishes that they could be. It should not be too surprising if they are. But we find similar disc-like symbols on artifacts found at other early settlements too. So for example, we have this chlorite vessel from Gobekli Tepe in southern Turkey. So that's to the east of Gobekli. It currently predates Gobekli Tepe. It's thought to be a little bit older. And you can see a scene on this chlorite vessel that appears to be a bird of prey with outstretched wings, with this double disc symbol. And next to it is a tall bird and a beak with a snake. And so it looks quite similar to that part of Pillar 43, and I suspect that these are the same set of symbols. And here is another example. So this example is now from Çatalhöyük, which postdates Gobekli Tepe by around 1,000 years. So more examples of disc symbols that could be representing the sun. So first of all, we have this mistress of animals, or Potnia Theron, and she has a circle on her belly and one on each knee. So perhaps she is a female solar deity, perhaps a spring equinox fertility deity. And on the right, we have this bear shrine from Çatalhöyük. Apparently this shape is a splayed bear with concentric circles on its tummy too. And I expect in this case, this shape symbolizes the constellation, or a constellation similar to Virgo, which was the summer solstice constellation at the time Çatalhöyük was occupied. And I'll come back to this symbol again later. Okay, so let's move on. So we now know, or we've established, that ancient hunter-gatherers were very likely interested in astronomy, and many of them likely kept track of the solstices and the equinoxes. So let's consider the deep time connections between constellations, animal symbols, and myth. So there are now several papers, like this small selection here, that make the case for a deep time connection between constellations, animal symbols, and myth. They make these claims based on analysis of widely dispersed myths from all across the world. Many of these myths are so similar and so widespread, it's argued that they originated before ancient hunter-gatherers migrated across the world. So specifically, we see the Pleiades are often symbolized in terms of 6 or 7 sisters or birds, just as we saw at the bottom of Pillar 18. And we find stories that connect the Plough or the Big Dipper constellation with an animal hunt, often involving a bear. And due to these similarities in the stories, as I said, it's thought that some of them could be even older than 50,000 years. So they could be incredibly old, and yet they have survived until today. So this shows, or it indicates, how persistent some kinds of astronomical symbolism could be. Now let's move forward in time to the Bronze Age, to Bronze Age Mesopotamia, thousands of years after Gobekli Tepe. We find in the historical Babylonian texts the names of at least 46 constellations. And most of these names are Sumerian, which means they likely date to the previous millennium or two, which means they could date back to the 4th millennium BC. And we also know from these texts that these constellation names are mostly the names of animals or mythological creatures or deities. Now let's move to Bronze Age Egypt, and we find a similar pattern. So we know their deities are associated with zodiac-like animals, and we know their religion was strongly related to astronomy, although we don't have a record of their pre-dynastic constellations. Nevertheless, in Egypt too, we see the association of astronomy, religion, and animal symbols. So we can say that in Paleolithic times, across the world, before Gobekli Tepe, long before Gobekli Tepe, and in the Bronze Age Fertile Crescent, long after Gobekli Tepe, there are strong associations between constellations, animal symbols, and myth. So when we find these statues at Karahan Tepe, which is a similar site to Gobekli Tepe, it's around 40 miles to the east. So when we find these statues composed of animal-human hybrids, it's reasonable to suggest that they are also mythological characters or deities, possibly linked with specific constellations. Now, Gobekli Tepe is thought to be a cultic center where the animal symbols likely represent mythological creatures. So it makes sense to also propose that they could be constellation symbols, especially when we see them next to geometric symbols, which might symbolize the sun. So now let's move on to consider the prediction of a Russian astronomer, Alexander Gerstein. So he was a professional astronomer and a historian of science, and unfortunately he died a few years ago. Nevertheless, he published a couple of papers about 30 years ago that predicted what I think we are seeing at Gobekli Tepe. But first, just before I talk about his work, let's first consider this article by Hughes from 2005. And in it, he argues that any ancient culture that tracks the solstices and equinoxes for more than a few generations, so more than 100 years, say, is likely to notice precession of the equinoxes. Now, Hughes was thinking especially of the builders of Stonehenge, but his argument can be extended to anyone who observes the solstices and equinoxes over a sufficiently long period. And since we expect many hunter-gatherer tribes also would have tracked the solstices and equinoxes over very long periods, many thousands of years perhaps, then according to his argument, we can expect many of these ancient tribes would have known about precession too. Now, normally, discovery of precession is credited to the Greek astronomer Hipparchus in the 2nd century BC, but Giulio Magli, an archaeoastronomer, documents several cases where he thinks it's obvious that precession was known long before this by the ancient Egyptians, by the Babylonians, and by the Indus Valley culture in Asia. We also have the well-known book, Hamlet's Mill, by de Santillana and von Deckend, which claims very forcefully that precession is encoded in many widespread ancient myths. So just to be clear, I'm talking about the process of axial precession of the Earth, which causes the solstices and equinoxes to cycle through the entire set of zodiacal constellations over a great year of around 26,000 years. Okay, back to Gerstein. So the same kind of reasoning led Gerstein to publish a couple of papers 30 years ago that suggested we can expect to find in prehistory a system of recording so-called world ages using precession and constellations. So he suggested that all 4 of the solstitial and equinoctial constellations could be used to write a date or a world age that lasted several thousand years. And he argued that sets of 4 constellations would likely have been used to write down the world age from around about 6000 BC onwards, as indicated there by that little red box. And the main reason he suggests this time, or the start of this system then, is because this is when he thought farming began in the early Neolithic period. But we now know that farming began somewhat earlier than this by a few thousand years. And in any case, the argument he makes about the origin of this system of writing world ages can be applied equally to hunter-gatherers. So their lives were just as dependent on the seasons as Neolithic farmers, at least away from the equator, that's the case, since all their resources are seasonal. In which case, we could find a system of writing world ages existed going far back into the Paleolithic, even before Gobekli Tepe. Now, without knowing anything about Gerstein's prediction at the time, this is exactly how we interpreted Pillar 43 in our 2017 paper. So we picked out Sagittarius, Pisces, Gemini, and Virgo as the 4 constellations, the 4 key constellations depicted on Pillar 43, representing the summer. So that's Sagittarius, the spring, Pisces, winter, Gemini, and autumn, Virgo. So we had no idea then when we wrote it, but our paper strongly supports Gerstein's hypothesis. Only it suggests the system was known many thousands of years earlier than he predicted. And in fact, it appears that the people of Gobekli Tepe seem to be even more sophisticated than he predicted, because they didn't just write down the 4 constellations. So if our interpretation of Pillar 43 is correct, they actually use the precise location or the precise position of the sun relative to the summer solstice constellation, which we interpret to be this bird of prey with the outstretched wings. So that's an even more advanced idea than Gerstein suggested. So now let's consider the strongest evidence that this is indeed the correct interpretation, which is the apparent correlation between what we see on Pillar 43 and what we expect to see if our hypothesis is correct. And we tried to statistically evaluate this correlation in our 2017 paper. Now, I'm not going to go through the statistical case here, but I do want to explain why we thought it was a very strong correlation, which means it's unlikely to occur just by pure chance. Okay, so here goes. So as already stated, our view was that the disk symbol likely symbolized the sun, and therefore this animal, a symbol might represent the summer solstice, or this bird of prey with the outstretched wings, might represent the summer solstice constellation. So that's the constellation behind the sun at the summer solstice. And we also expect these other 3 sort of handbag-like symbols are actually sunset symbols. Okay, so they're not handbags, it's the semicircle that's important. Sunsets, and the 3 animal symbols next to them are, we think, represent the constellations corresponding to the other 3 astronomical days of the year, the equinoxes and the solstices. So that's our hypothesis. Now, if we use software like Stellarium, which shows reconstructions of the Greek constellations, we find that the only constellation that has a pattern like the bird of prey here, and that is on the path of the sun through the sky, which is known as the ecliptic, is the teapot asterism of Sagittarius. And they do seem to be quite a good match. And using Stellarium, it's easy to see that on the summer solstice, this position of the sun relative to the teapot asterism of Sagittarius corresponds to about 10,950 BC, to within a few hundred years, which is close to the suggested date of the Younger Dryas impact. Nevertheless, if we take this vulture or eagle to symbolize the part of Sagittarius as it sets on the western horizon, then we can expect that Scorpius should be directly below it, and we actually do see a scorpion exactly where we expect. Also, if our hypothesis is correct, we expect to see Lupus, which is the mad dog or wolf constellation, just to the left of the scorpion, and indeed that does appear to be what we find. In fact, the posture of this canine symbol is exactly right for Lupus. So this is already quite a strong correlation. And again, if our hypothesis is right, we expect to see Ophiuchus struggling with his giant serpent over here, but what we find instead is a tall bird struggling with a snake. So that's a partial symbolic match. But the shape of this symbol here is not that dissimilar to our Ophiuchus constellation. So then if we move up to this sunset icon, if our hypothesis is correct, then at the time of the Younger Dryas impact, we expect to find Pisces. I'm showing it over here as well. We expect to find Pisces here for the autumn equinox constellation. And although we don't see the Greek symbol of 2 fishes for Pisces, we do see a bending bird symbol. Let me get my cursor. We do see a bending bird symbol with very similar right angle shape, which is just perfect. So that's a really strong clue that we've got this right. It's one of only 2 Greek constellations that has this overall shape, the other being Aquarius. And then in the middle, we expect to find Gemini, which we know as 2 people with arms linked and 4 legs extending below. But although we don't see that, we do see a quadruped viewed from the side with legs extending below. Now, there are only a handful of Greek constellations that are quadrupeds viewed from the side with legs below, so that's a reasonable match as well. And then on the right, we expect to see Virgo, which is basically a vertically oriented splayed quadruped, and that's exactly what we see here. Again, there are only a few Greek constellations with that overall form, so that's another good clue that we've got this right. Now, a few of those individual correlations could be coincidence, but when they appear all together in the same place, it's a very strong indication that we've got this right. Now, Gobekli Tepe's excavators wrote a response to our 2017 paper where they strongly doubted that these animal symbols could symbolize constellations similar to the Greek ones. But they didn't provide any evidence to support that view. It was just their opinion. So it's worth considering, what do we really know about the origin of the Greek constellations? So what are the facts? Now, the most cited papers on the origin of the Greek constellations are these ones up here. So this pair of papers by Rogers in 1998. Now, Rogers argues that it's likely that the Greek constellations, zodiacal constellations that is, those that are on the path of the sun, he thought they were imported from Babylon around 500 BC, while all the other non-zodiacal constellations were probably cobbled together from various sources. A few of them are mentioned in 7th or 8th century BC tales by Homer and Hesiod, for example. Now, the evidence that Rogers supplies is not at all strong for this story, and yet his abstract and conclusion are stated as though this is a fact. So if you just skim his papers, you could get the wrong impression that this story is a fact. It isn't. It's conjecture. His view is that because the Greek zodiacal constellations are known to exist in Babylon before they are known in Greece, that they must have arrived from Babylon. But clearly they could have been imported to both Greece and Babylon from a third neighboring country like Turkey, where we find Gobekli Tepe. In fact, Rogers' story is directly contradicted by a 2nd century BC account by Pseudo-Eratosthenes, who recounts an earlier tale by Hesiod, which means the tale likely dates to the 7th or 8th century BC, in which he already mentions the Scorpius constellation. So that would mean the Greeks already knew at least some of their zodiacal constellations before they're supposed to, or at least supposed to by Rogers, that is. However, we know that much of Greek myth was shared with or acquired from the Anatolians, and it's thought there was a lot of movement of people across the Aegean Sea. So it makes sense to suggest that both the Mesopotamians and the Greeks might have obtained their constellations from a third source in Anatolia, which shares a border with both of them. And of course, this is where Gobekli Tepe is. Now, it's worth pointing out that what is likely a lunar solar calendar has been found at Hattusa, capital of the Hittites in central Turkey. And it's depicted in terms of rows of local deities which symbolize the days of the calendar. And these deities include both male and female solar deities. Okay, so that's a likely lunar solar calendar in mid-second millennium BC Turkey, not far from Gobekli Tepe. Right, now I want to consider, the Master of Animals symbol. So this symbol is seen across many cultures over thousands of years, both in Bronze and Iron Age cultures in the Near East and in Celtic regions and beyond. And the ones I'm showing you here are from the Eastern Mediterranean region. Now, usually the master, which is sometimes shown as a mistress, is shown between two opposing animals and is often holding them at arm's length. So now many of these symbols are thought to be related to the Greek constellations. So this view is discussed by Rogers in the papers that I mentioned earlier. And of course, for some of these cultures, we know there are direct links between constellations and animal symbols. So here's an early example, a late example. We have a mistress of animals in the form of Artemis from Greece in the 1st millennium BC. Here are some earlier Minoan examples, and we can see that this animal here being held is a goose, which is consistent with the Gobekli Tepe zodiac I described earlier, where we take the goose to symbol Libra, which is the autumn equinox constellation at the time of this artifact. So here is an earlier example from the Indus Valley culture, and so here we have a seated master surrounded by 4 animals, consistent with Gerstein's hypothesis for writing a world age. And here are some even earlier examples from Iran and Sumer and Egypt, which are all consistent with the Greek zodiac and Gerstein's hypothesis. Okay, so we've taken this master of animal symbols back to the 4th millennium BC, but it seems to go back even further than that. So here is an example from Iran in the 5th millennium BC. Okay, a master there, and next to it is a symbol, a similar symbol, which is clearly a constellation, or it looks to be a constellation. We can see stars and V symbols in the background, and we'll come to them later. And this picture looks, looks a lot like the Greek Ophiuchus constellation. And by the way, Ophiuchus is the autumn equinox constellation at the end of the 5th millennium BC. But we have, remember I mentioned this earlier, we have an even earlier example from Çatalhöyük, 7th millennium BC. So this is the Potnia Theron, mistress of animals. But just in the last couple of years, an even earlier example of the master was discovered in a little village called Şeyberk, not far from Gobekli Tepe. And it's thought to be from a similar time as Gobekli Tepe. And although in this example the master is not grasping the animals, it's clearly very similar to later master symbols. So what does all this mean? I think what it means is that symbolism can survive from the time of Gobekli Tepe through to Bronze Age, to the Bronze Age, and then to ancient Greece, because we see what appears to be the master or mistress of animals throughout this period. And moreover, it's generally accepted that the animal symbols in the later Bronze Age examples might be related to the Greek constellations. So therefore, it's entirely possible that the animal symbols at Gobekli Tepe are related to the Greek constellations too. Also at Çatalhöyük, which I've mentioned before, there are 4 kinds of wall installation or shrines. So these are made from layer upon layer of plaster and paint, probably repainted annually. And there are only 4 kinds of these shrines. And again, this is what you'd expect given Gerstein's hypothesis, with the 4 shrines representing the 4 solstices and equinoxes. We also have these handbag type artifacts. So here is one of those, and you can see, so I suspect the shape of this handbag actually symbolizes a sunset. So it's the semicircular handle shape that's important here, not the shape of the bag. And this one has a master of animals on it as well. And we know that these animal symbols are consistent with the Greek zodiac and Gerstein's hypothesis. Now, there are lots of other examples of these handbag-shaped stone weights from Jiroft in Iran, and they mostly have zodiac-like symbols or serpents on them. And on some of them, the semicircular shape is really clear. But we can find this sunset-like semicircle shape next to zodiac-like animal symbols on even earlier artifacts. So here is a pair of animals standing on top of these sunset-like symbols on the Uruk vase. So this is a tall vase that was recovered from 4th millennium BC Uruk, Sumerian city in Lower Mesopotamia. Now we have an unfamiliar goat symbol next to a more familiar feline symbol. So probably the ibex or the goat is a zodiacal creature, just one that we're not familiar with yet. In fact, astronomer Willy Hartner in 1965 suggested the ibex or goat symbol in this kind of context likely symbolized a constellation similar to Aquarius. Furthermore, on the right here, we know from an early form of Sumerian writing or proto-writing which preceded cuneiform, that a semicircle actually does mean the sun. Okay, so this table is from the Encyclopedia Britannica, and it clearly shows the semicircle symbolizes the sun. In fact, we also see the sunset symbol is used, turned on its side, is used to denote different measures of time. So 1 day, 10 days, 1 month, and so on. And here's another example, I think, of this system, this time in the form of some rock graffiti discovered in the desert near Thebes in Egypt. So Yale archaeologists Darnell and Darnell, who discovered it, thought this scene told a story about a pre-dynastic scorpion king, or pharaoh, because this hawk symbol in Egyptian hieroglyphics signifies Horus, and therefore this pair was read as Scorpion King, and they thought this guy over here was the Scorpion King. But they weren't so sure what this symbol at the top might be. Perhaps it was a boat or a seat, but we can now interpret this whole scene as a zodiacal date using Gerstein's theory and the Gobekli Tepe zodiac plus the ibex as Aquarius, as suggested by Hartner. In this case, this symbol is now a sunset, and this guy becomes Orion with his belt. It's also worth noting this snake and tall bird. We see a very similar symbol I just showed you earlier on Pillar 43 at Gobekli Tepe. Remember, we thought it could represent Ophiuchus. But now let's have a look again at Pillar 43. So we have exactly the same kind of sunset symbols next to the same kind of animal symbols, all of which are consistent with Gerstein's hypothesis. But let's just focus on this symbol at the top right of Pillar 43. Now, it's probably the same symbol that appears on one of the 4 shrines at Çatalhöyük that I showed you earlier. Now, I don't know of any other theory that can explain why this symbol at the top right of Pillar 43 appears next to a semicircle, while at Çatalhöyük it has a full circle on its belly. But we can easily explain this if it symbolizes a constellation similar to Virgo, because Virgo is the spring equinox constellation at the time of the Younger Dryas impact, but it's the summer solstice constellation at the time of Çatalhöyük. Okay, so now we are in a position to discuss the possibility of a solar calendar on Pillar 43. So how does that work? So let's take a look at these geometric symbols here above the disk, which we think is the sun. So you'll see this top row of V symbols, and if you count them carefully, you'll see that there are 14 double Vs with alternating vertical orientation with a single V at the end, just here. Now I suggest this is counting the days of a lunar cycle, and here's how. So if you count the upright Vs, now you'll count 15 from right to left, and then 15 back again, that makes 30. But if you count the 15 upright Vs right to left, and the 14 upside down Vs back again, then you'll get 29. Now the lunar cycle alternates nearly perfectly between 29 and 30 days. So that's the number of days between successive full moons. A very similar counting device was reported by Alexander Marshak back in the 1970s. In that case, it was carved onto a piece of Paleolithic deer antler. So it seems people have been counting the lunar cycle for millennia, even before Gobekli Tepe. Now, underneath this row of V symbols, we have 11 little boxes. Okay? If we take each box to mean repeat the above count, then we have 11 more lunar cycles, which totals 354 days. But underneath the 11 little boxes, we have 10 more V symbols. So if we add them to the count, we have a total of 364 days, which is obviously just 1 day short of an entire solar year. So we have a day missing. But look how this pattern seems to be focusing down onto the disk symbol. I suggest that this is a deliberate design. It's telling us that the disk represents the final day, so the 365th day in the count, which we take to be the summer solstice. And to reinforce that view, see this V symbol at the neck of the bird of prey. So this V symbol could be telling us directly that this scene is a day, which we take to be the summer solstice. So why is this geometric design here? What's its purpose? I suggest the whole point of this design is simply to tell us that this scene is depicting a special day in the year. In other words, they were using constants of nature, the lunar and solar cycles, to tell us two things. First, that a V symbol represents a single day. And second, by counting only up to 364, they were making it as clear as they possibly could that this scene represents a special day in the year, which we take to be the summer solstice. And of course, this story dovetails perfectly with our 2017 paper, which we suggested, where we suggested that this scene represents a date. So we have two independent ways of arriving at the same conclusion. We can either focus on the geometric symbols, or we can focus on the animal symbols. Either way, we can arrive at the same conclusion, which is that this represents a special day in the year, likely the summer solstice, and therefore a date using precession. Okay, so that's the piece of Paleolithic deer antler reported by Marshak that I mentioned earlier. Now, it's also worth noting that the Urfa man statue, discovered in Şanlıurfa near Gobekli Tepe, and the Şeybük wall carving, they both have V symbols at their neck, which you can see here. So V symbols at the neck probably mean something related to time. They're not just decorative. And this supports the idea that the V symbol at the neck of the bird of prey on pillar 43 that I just showed you means something important. It's probably not just decoration or plumage. Okay, so now let's have a look at another different pillar at Gobekli Tepe in enclosure D. So this is pillar 33 in enclosure D. And here we can see bunches of snakes leaping or radiating from the legs and torso of a fox. And on the other side of this pillar, you can see a similar scene where the snakes are projecting from the legs and torso of a tall bird. So what should we make of this? Well, I think the evidence is now very strong that these animal symbols represent constellations. And if that's true, then these snakes almost certainly symbolize meteors. They're probably very nice pictures of a meteor stream. But which one? We already decoded the tall bending bird here, as it also appears at the top left of pillar 43, where it symbolizes a constellation similar to Pisces. And the fox on the other side of this pillar is very similar to the northern part of Aquarius. Now, we expect that the Taurid meteor stream at the time that Gobekli Tepe was occupied would have radiated from the direction of Aquarius and then Pisces over the course of several weeks. So this pillar could be a very nice picture of the Taurid meteor stream, which is the same meteor stream that is blamed for the Younger Dryas impact. Now you can see in this picture that the snakes converge on the inner narrow face of the pillar. So let's just look at a sketch of that. And you can see there are more V symbols, although they're upside down. So are these V symbols telling us how long the meteor stream was visible? 13 days from the direction of Aquarius and 14 days from the direction of Pisces. That would make some sense. So putting this all together, we seem to have a date on pillar 43 consistent with the Younger Dryas impact. We also have a headless man, probably symbolizing death. And on pillar 33, we have a nice picture of a meteor stream, which we think is probably the Taurid meteor stream. So I think it's clear that the message here is one of remembrance, that this enclosure D, is designed to memorialize the Younger Dryas impact. And now for the last piece of the puzzle, let's go back to where we started with pillar 18 at the center of enclosure D. It seems that we guessed correctly that these symbols are astronomical. So in that case, does pillar 18 symbolize a comet deity with the comet head and tail here? I think it probably does. There is also a fox carved into the side of this pillar, and this loincloth has been interpreted as a fox pelt. So is this comet also from the direction of Aquarius, and therefore a comet in the Taurid meteor stream? Could it be the Younger Dryas comet, perhaps? It seems likely to me. So cosmic impacts, so to conclude, cosmic impacts might have been recorded in prehistory using artworks and an astronomical code consisting of 4 zodiacal animals that signal a world age, consistent with Gerstein's hypothesis, depictions of death, and depictions of meteors. And perhaps the construction of enclosure D in Gobekli Tepe more generally was motivated by a comet cult after the Younger Dryas impact. We should note that fear is a very highly motivating force, perhaps sufficient for the construction of a site like Gobekli Tepe. And it appears that people knew how to count and record lunar and solar calendars and write zodiacal dates using constellations and processions at this time. And it seems that we can trace the origin of several Greek constellations back into the Paleolithic. So that's, I would just like to end with a few attributions for the correct record. So this whole scheme, this interpretation, was started by Dr. Paul Burley, who is an archaeologist. So he suggested interpretation for the sun and these two constellations, these two animal symbols, and a date using precession, although he thought it was the winter solstice and therefore arrived at a different date. This top line of V symbols here was discovered, if you like, by John Gordon, a psychiatrist who emailed me a few years ago about this. And as you can see, there are a few other contributions to this whole astronomical interpretation. So I'll finish there. Thank you very, very much, and I will take any questions that you have.
So thank you to Professor Martin Sweatman for his overview about the representation of the calendar and astronomical representation of starting from Gobekli Tepe. If I may, I want to thank you because you stressed and highlighted how was important the observation of sky and stars for ancient community. I mean, for the society when they started to play agriculture, and really enrooted link between the observation, the seasonal cycles, and the beginning of agriculture. Sometimes we use this definition like a basic, but we just have to study and research more about the role of the sky and star observation and the components in these starting agricultural periods. So I don't know if there are many comments or other suggestions in between our.
Yeah, I mean, I would add to that really this interest in astronomy, we should expect that it goes back way before even agriculture began.
Yeah.
Because hunter-gatherers were just as dependent, at least away from the equator. Hunter-gatherers are just as dependent on the seasons as farmers. You know, their entire lives, all of their resources essentially are seasonally dependent. So it would make sense that they would take a great interest in the solstices and equinoxes. In fact, that's what Hayden and Villeneuve write about in their review of the Paleolithic period.
Yes, sometimes we forget this. Probably they started in advance to study these aspects before to go ahead in some experimental agriculture or mixed systems. So it is a really useful perspective for our studies at that moment, I mean. So again, there is anybody that wants to ask something or some suggestion to propose to our professor?
Yes, first of all, I want to thank you for your presentation, really very fascinating. And I have a question. In your opinion, why they represent the constellations as animals or animals' god?
Why as animals?
Why they choose animal for represent the constellations?
I mean, that's a good question. I don't know the answer. Possibly because they are observing these animals in different postures. So, you know, each animal or different animals will have different postures. Animals have different animals have different configurations in terms of their limbs, and so that it's quite useful. That quite an easy way to represent different shapes that they can see in the sky, because the animals that they see around them have lots of different shapes. And I guess they have a great interest in the animals themselves anyway. You know, it's part of their life.
Yes, of course. Thank you. Thank you.
So in the meantime, I want to remember to everybody that these lectures will be available on our site. Feel free to ask if someone else wants. So I think that we can say again thank you to Professor Martin Sweatman again for illustrating to us this intriguing argument and topic that is opening new perspectives for us, of course, because we are not so educated to consider these aspects. Usually, we educated to make some artistic just consideration. This is something more. Is a way to give back a sort of original interpretation of the drawings or representation of ancient times. So thank you again for this fruitful seminar, and hope to cooperate again in the future. Thank you also by Professor Lorenzo Nigro. So this was the last, for the moment, seminar. Probably in the future we can go ahead with other spots. Is it right, Domizia? Yeah?
Is it? Yes, it is right.
Inshallah, we can in the future. So thank you, everybody. See you soon. Bye.
Thank you everyone. Thank you, Daria.
Bye.
Thank you, Domizia.
Thank you.
Thank you. Bye.
Bye.